Oh, looks like we got a little puzzle right here. So there's a vector. It makes a 40-degree angle with the positive x-axis. So let's see, this would be 90 degrees. Right through the middle would be 45, so it's approximately like this, where this is 40 degrees. And then also, its magnitude means its length. So the length of this vector is 12, whatever the units are, feet, meters, millimeters. And then find a vector means what are the x and the y that creates that vector. So what we could do is just drop this down so that we have a right triangle. This would be x and this would be y. And now we could just use sine and cosine. For example, sine of 40 degrees. So sine is opposite over hypotenuse. So that's y over 12. Or in other words, multiply both sides by 12. So y is equal to r sine theta, just like when we were doing parametric and polar functions. So this shows up a lot. Likewise, I could use cosine. So cosine of 40 degrees is equal to adjacent over hypotenuse. Then multiply both sides by 12. And just like with polar functions, it's saying x equals r cosine of theta, y is equal to r sine theta. Now, what are those numbers as decimals? Is it in degrees? Good. 12 sine of 40. So the y equals 7.713. And 12 cosine of 40. The x is equal to 9.193. And then the last thing is, it said vector, so you should write it in vector form. So put the angled brackets, and then x goes first, 9.193, and y goes second, and then the other angled bracket.